we're going to need to build the functionality into the bullet tracer point cloud. If I open up the Explorer and I open up the rifle rig, I'll access the bullet tracer point cloud ice tree by pressing Alt-9, and I'll actually point the action clip layer to the appropriate model. So for this one here, it's looking for the Mulcore reference model parent. So what I can actually do here is access the model I'm looking for. So the rifle rig, if I go into the Mulcore reference model and into the actual reference model here and press not Alt-9, but Alt-0 to access the animation mixer, I can pull in the weight of the action clip as I get data. And that's actually what I'm looking for. So I'll replace here and there. So now the ice tree should work properly. And just to be sure, if I turn off the weight of the clip, and use it to drive the rate, that would help if it was actually plugged in. Okay, so we get nothing. And I can turn it off. Okay, cool. So we know everything's working there. So to extend this, the functionality of this this ice tree now, we want to be able to call up a bounce-off surface compound. We want to be able to calculate this surface, and if we bounce off it, we'll get particles to emit new particles, to spawn new particles. The way we're going to do that is call up a surface interaction compound. We'll look up the bounce-off surface and bring it into the graph. And I'll insert a new port after I've aligned on velocity, and I'll execute the bounce-off surface into port 3. I'll make some room for some of these other compounds. And the surface I want to bounce off of, I'll look for in the Explorer. It'll be in the mech character, in the robot tank. So if I open up the tank, I have access to all my parts. So I guess I should look for the legs. That'll be my geometry to look for. So I'll press F3 and drag it into my graph. If I resolve the bounce-off surface compound, I do want to make sure that, well, in this case it doesn't really matter if I'm looking for a deformed collision or a static collision. It's not like these pieces are enveloped, they're just parented to the mech bones. So I don't really need to worry about it being a deformed collision at all, but I can just leave the default as is. When it comes to the bounce factor, I don't want the particles to bounce around too much. In fact, I want them to die when they hit the surface. But I also want them to emit new particles as well. So that's what we're going to look at doing next. The particles that we've created, the emission particles, are going to represent state 0 of the ice tree, the first state they're born into. And when the particles hit that surface, the laser blast hits the surface, we want the particles to be deleted. So the first branch I'm going to build in right after I bounce off the surface is to spawn new particles when they collide, and then after that to delete particles if they're in the first state. Spawning allows us to transition the particles into a new state. So if I choose to spawn on collision, you'll notice that when I execute on collide, I can specify a new birth state for the particles. So these will be in state 1, and I'll give them a red color to differentiate them from the particles in state 0. So I want to run a test if the particles in state 0 have collided with the surface, and when they do, spawn new particles and then get deleted. So let me look up equals and an if node, and let me get a particle state. So if I look up the state ID, so I can get the particle state ID, and if it's equal to state 0, then simply delete the particle. So I'll look up the delete particle and execute if true. And we want to execute this branch every time a particle collides with a surface. Okay, so that works really well. We're getting a huge amount of particles blowing off here. So at least we know that this compound works. It's now just time to obviously refine the effect some more.